So the title of the session is What, Why and How of Concept Maps. We are going to use this idea, this technique of concept mapping and learn 2 or 3 diverse issues related to it. One is the technique itself and why it's useful and how to do it. And second is how do we use it for course design and how do we connect the syllabus and the learning objectives in our course. And thirdly, what technology tools can help us actually create a concept map. So what you have done in terms of course planning so far is we started by discussing and looking at the need for learning objectives. Started with the mismatch between teacher and student and so on. Then you wrote learning objectives for a topic in your course, and today in fact you wrote learning objectives at various cognitive levels for a specific topic or unit in your course. The next steps of course planning is that you need to think about the learning objectives for the entire course or at the course level. What I mean here is that the course, your course or the subject that you are teaching has various modules. Usually it's about 5 to 8 modules per 40-hour course is a very standard number. And then each module has topics or subtopics. Again there are 3 or 4 or 5. So totally there are about 40 or so subtopics, because if it's a 40-hour course we usually do one subtopic in every class. And what we wrote learning objectives for were at the lower as in were at the more detailed specific level. And now we have to think about the entire course and see what is it that we want our students to be able to do at the end of the entire semester at a synthesized level. So before you write your own course learning objectives, let's look at a few examples. So I have examples from 3 different courses, and this example is on fluid mechanics. Again I have just chosen 3 diverse topics, so let me tell you what these are. So perhaps you will be able to connect to one or more of them. One is on fluid mechanics, one is on basic electromagnetic theory, maybe a first or second year course, and the third one is a first year course on computer programming. So hopefully a large number of you will be able to follow at least one or more than one example. So for this course on fluid mechanics, what the teacher wants the students to be able to do at the end of the course finally is describe physical properties of the fluid and explain the consequences of these properties, state some conservation principles, create models of different types of fluid flow, and determine basic forces and moments acting on different profiles and shapes in a fluid flow. So if you look at these, they are actually at various cognitive levels. The one which says state the conservation principles are at the recall level. So as we are looking at the objectives, let's also try to pinpoint which cognitive level they are at. This is not written in order in terms of hierarchy, but it's perhaps written in order in which they appear in the course. Whereas describe properties of the fluid is and explain the consequence could be at understand level. Determine basic forces could be an apply or analyze level objective, and create models of fluid flow can be at the highest create level. So the other thing you want to observe when you look at course level objectives is that they are written at a broad perspective. It's not, we are not saying any one specific topic or one specific application, but these are techniques and knowledge and skills that we want our students to be able to learn and do after the entire course. So I will just pause for about 10 seconds so that you can read this, and then we will go to the next example. So the next example is a course on electromagnetic theory. Again this is a basic course, perhaps even at 12th standard in some curricula they might do it, but definitely at the first year level a lot of departments run a course like this. So if you look at how it starts, it says given an electromagnetic field problem. In the sense all the objectives are with respect to a situation where some electromagnetic fields are described, exist. Given an EM field problem, students will be able to use the principles of electromagnetic theory to conceptually describe behavior of the charges and currents. So the first bullet here is, it's actually at an apply level, but it's saying that qualitatively and conceptually students should be able to reason. The second one says apply Maxwell's equations to quantitatively solve problems, and the third one is derive expressions for energy. So it's only 3 objectives, but this is all the problems and all the examples in the entire course usually will fit either one of these or some objectives that are under these. In the sense, to be able to conceptually describe behavior of currents and charges, the student should know what is a current and what is a charge and should know the laws and so on. Those are not stated here. They will come in the unit level objectives. Finally, last example, and the reason I am showing you all this is because the next activity is where you will write your own course objectives. So in this last example, this is a course on computer programming. It can be in any language, it does not matter. Students should be able to trace code and predict output of a given program. So they should be able to read a program, understand what it is saying, and be able to predict what the output of that program is. What kind of a program? The ones involving pointers, functions, parameter passing and so on. They should be able to write a C++ class for such applications. Here they give an example. They should be able to design and implement applications, that means they have to write large code, and they have to be able to create a simulation for an example like this. So again I am going to pause here, since a number of you might be teaching a computer programming course, so that you get an idea of how to write course level learning objectives.